All right, this will be a very quick Pythagorean Theorem review. So if you have any questions, be sure to email me. All right, so I noticed that you guys are having trouble with multiplying your radicals. And don't forget that, so you're going to end up with a problem that might have the square root of 5 squared, okay? The square root of the 5 squared is the same as saying square root of 5 times square root of 5. The square root of 5 times square root of 5 is the square root of 25. What is the square root of 25? 5. So what do you notice? The answer is 5. And what's under the radical? 5. So any radical times itself is just the number without the radical. So the square root of 5 times the square root of 5 is 5. The square root of 10 times the square root of 10 is 10. The square root of 20 times the square root of 20 is 20. The square root of 15 times the square root of 15 is 15. Okay? Just a refresher, I need you guys to remember this. Write it down. Take your own notes. Be sure to take notes. All right, so here is the Pythagorean Theorem. A squared plus b squared equals c squared. If you notice, the small a and b, those are the shorter legs. The a, opposite from angle A, side A, and then b. You can only use this formula in a right triangle. It has to be a right triangle. Okay? Has to be. All right, so the two sides squared, the sum of those two sides is equal to the hypotenuse. The hypotenuse. Sorry, I'm not going to edit that either. But the hypotenuse, okay? All right, so we have a squared plus b squared equals c squared. Your longest leg, the hypotenuse, will always be c. But if you notice here, I wrote the two triangles two different ways so that you can see that either side, this could be a or this could be a. A squared plus b squared equals c squared. Same thing. A squared plus b squared equals c squared. The only thing that stays the same is c, and c is always opposite from the right angle. Okay? The longest leg is always c. Remember that. Let me just draw one. So here's the right triangle. 3, 4, and I want you to find the missing side. So you're going to say a squared, 3 squared, plus 4 squared equals the missing side, x squared. 3 squared is 9. 4 squared is 16. 9 plus 16 equals 25. All right, so I have x squared equals 25. To solve for x, you see that it is squared. To get x by itself, when you have the exponent, you have to take the square root of both sides, okay? So the square root of x squared is x, and the square root of 25 is 5, okay? So this missing side is 5. All right, so now we're going to do some example problems and follow along with your notes. You should have these in your notes. So you have a squared plus b squared equals c squared. So here you're trying to find c squared. So let's do 8 squared plus 12 squared equals x squared. What is 8 squared? 8 times 8 is 64. 12 squared is 144 equals x squared. 144 plus 64 is 208. All right, we're trying to get x by itself, so you're going to take the square root of both sides. So the square root of x squared is x. And the square root of 208, it is not a perfect square, but there is a perfect square that goes into 208. And if you don't have a calculator that will do it for you, you already know how to do it. The largest perfect square that goes into 208 is 16. 16 times 13, actually. All right, what's the square root of 16? 4. And what's left behind? 13. So if you simplify the radical, it is 4 root 13. Most of you understand the Pythagorean theorem, but you're having trouble simplifying your radical. All right, same thing here, but this time we actually have c. If you notice, we have a c. So you have a squared, 9 squared, plus b squared, x squared, equals 13 squared. So you have 81 plus x squared equals 169. 9 squared is 81, 13 squared is 169. We're still trying to get x by itself, so I'm going to subtract 81 from both sides. So I have x squared equals 169 minus 81 is 88. So I'm going to have to take the square root of both sides. Again, 88 is not a perfect square, but the largest perfect square that goes into 88 is 4. 4 times 22 is 88. So I take the square root of 4, which is 2, and this is left behind. So my final answer would be x equals 2 root 22. Again, most of your calculators will do it if you put in square root of 88. It will go ahead and simplify it for you, and I don't mind you using the calculator, guys. All right, now this is where we get to our radicals, and you can't be intimidated when you see a problem like this because you know how to do it now. I have my A, my B, and of course my C is always across opposite my right angle. So A squared is the square root of 7 squared plus x squared equals the square root of 15 squared. All right, so what is the square root of 7 times the square root of 7? We talked about it on that first screen. It is just 7. The square root of 15 times the square root of 15 is 15. So we're solving for x. When I subtract 7 from both sides, I get x squared equals 8. What perfect square goes into 8? 4. So I have x equals 4 times 2. Square root of 4 times 2. Okay? The square root of 4 is 2, and what's left behind? 2. So my answer is x equals 2 root 2. All right. Here, again, I have C, but I'm going to solve for my A this time. And then I have B. So I have A squared, which is x squared, plus B squared equals C squared. So x squared equals 10 squared is 100. Uh-oh, I didn't mean to put equals. Now it won't let me erase it. X squared plus 10 squared, which is 100, equals 15 squared, which is 225. When I subtract 100 from both sides, I get x squared equals 125. I take the square root of both sides, and I get x equals 125 is not a perfect square, but 25 does go into 125. 25 times 5. The square root of 25 is 5, and what's left behind? 5. So x equals 5 root 5. All right, guys, I know that was fast. It's just a review, but please email me with any questions you might have. I need you guys to understand the Pythagorean theorem so that we could move on to our trig functions, okay? Have a great day.